Copyright in these lectures is either owned by the ANU or a third party who has licensed the ANU to use it. Students may use the recording for personal study only. No lecture may be communicated online, copied or shared without the prior permission of the ANU.
Anyway, our office is next to Davy Lodge on Childers Street. You can email us, find us on Facebook. Probably find us on Facebook is the best way to start. But we'd love to see you all today or any other time if you have some questions about Exchange, want to know where you want to go. Feel free to pop by. We'll be happy to talk to you. Anyway, make sure you discover engineering today. Bye.
As the last couple of people trickle in, and not to waste a good silence, I will go through a couple of administrative matters before we pass over to the guest lecturer this morning. So, the discipline workshops all started last week. My apologies to the couple of groups at 8 a.m. on Tuesday who were locked out. Security assured me that that wouldn't happen, but there are always teething problems at the beginning of the year. So my apologies, and hopefully you won't run too far behind. My understanding is that the workshop leads have organised a little bit of catch-up for the one or two people who didn't manage to complete in those times. So hopefully no harm done, and it meant that that you got to start a little bit later while your brains are perhaps a little bit more functional. This week and next week we're finishing off the discipline workshops, and you are expected to be working on your car project. The toolboxes, including all of the parts, the standard parts kit and whatever else, was supposed to be released at the end of last week, but my apologies, my boss, who is also today's guest lecturer, sent me overseas at short notice and it didn't quite happen, so blame him in your guest lecture reflections if you wish. Today, I'll start the toolbox release today and over the rest of this week. It's still pretty early days, so there's no real rush for it, I hope, but watch out for an announcement on the Watton News Forum. There are a couple of posts up on the forum regarding some clarification around using your own 3D printers, your own parts and so on, so make sure that you read those if you have not. Team charters all submitted, the marks have all been released as well. If you were the person who submitted it, then you will see the mark twice in the gradebook, once against the submission and once in a dedicated column on the side. Everyone else will just see the mark in the one dedicated column marked Team Charter. If you believe that you should have got a mark for that and your team charter box is still showing empty, then please email myself or Jenny Simmons or Claire Idris as soon as possible, because it means that in our sheets you haven't been allocated a project group. And if you haven't been allocated a project group, then you're going to have many more problems down the track than just your team charter. So as I say, make sure that you get in touch there. On that note, I'm going to hand over to today's guest lecturer, who, as I say, is also my boss when I'm not wearing my teaching hat. His name is Professor Daniel Shattuck, here from the ANU. He lectures up in physics, or is a professor of physics, I suppose. He hasn't lectured in a couple of years because, he's too busy detecting gravitational waves, as it turns out. As many of you will have heard in the science news at the end of last year, we as humanity have now discovered gravitational waves, which are little perturbations in the fabric of space-time itself. And now the paper in which that discovery was announced, it had about 700 authors on it or something like that. It's a big multinational collaboration. But here in Australia, we had some of the key personnel, and here at ANU we had some of those key personnel, of whom Dan Shattuck is one. So he's been working in high sensitivity measurement for a long time. By high sensitivity, I mean LIGO, the detector for gravitational waves, has a sensitivity, can measure changes in distance to about 1/10,000th the diameter of a proton. Alright, so pretty sensitive. With all this expertise in test and measurement, he also decided in 2014 or so to found a startup company called Liquid Instruments, which is being spun out of the ANU as we speak, and of which I'm actually an engineer as well. So with that, and hoping that I haven't taken too much thunder out of the speech itself, Dan Shattuck.
Thanks, Ben. Can you guys hear me okay up the back there? So yeah, like Ben said, I'm a professor here at the ANU. I was actually an undergraduate here in physics many, many years ago now, and I've been a professor long enough now that I can just introduce myself as a professor without giggling after I say it, but it's still a fairly new thing to me. So my title is a little bit misleading. It's the title of the talk that I grabbed this morning to prepare this lecture. And I'm going to be talking about a bunch of stuff. There's also a bunch of stuff that's going on here at the ANU that I won't be talking about today. So this is one of the things that my group does. I'm over the other side of campus, near the engineering building, just past the engineering building, in what used to be called the Department of Physics. But now it turns out that the type of stuff that we do is in experimental physics. The people that we need to do that are people like you. So most of my graduate students now and postdocs are either engineers from the ANU or joint engineering science students. So you guys are really the sweet spots. I'm looking for kind of the next generation of people to come through and do all my work for me in 4 or 5 years' time. So I'll start talking about gravitational waves. We might talk about some other things as we go along, but some of the things I won't be talking about today. So I'm also involved in the space debris project that's going on here in Canberra. So there's a $20 million investment here to build a system that will detect space debris with lasers, and not only detect them with lasers, but actually crank up the laser power and be able to push the space debris around with lasers from the ground. Which is an incredibly ambitious project. When I first heard about it, I thought, that's crap, that's never going to work. But if you run the numbers, it looks like we're pretty close to being able to do that. So this would mean that we could avoid catastrophic collisions between debris and spacecraft and debris if we can figure out where the debris is quickly enough and then turn up our lasers and push it out of the way of a collision. So that's a really exciting project that's going on here. A lot of other stuff that we're working on now is in the communications area and free space laser communications. So I have 4 different projects going now to develop laser free space communications. And this is a really interesting project because it brings in a bunch of expertise from my laser background, a bunch of expertise from comms and digital signal processing, and then also a bunch of stuff from the field of astronomy, where over the last 20 years, astronomers have developed adaptive optics techniques to take out the atmospheric fluctuations out of their pictures when they're taking of deep space images. And to be able to recover the diffraction limit of telescopes. Turns out all of those techniques are directly applicable to doing optical communications, which there are some companies around the world, Facebook and Google, are working very hard on free space laser comms to provide internet to the world by linking up a bunch of satellites, high altitude balloons and drones. So there's some pretty cool stuff going on around here that I'd encourage you to try and learn more about. And if you're interested in these sorts of things, there are opportunities for undergraduates to come in and spend 6 months working on a project with the engineers that are developing it. And I think Ben's a pretty good point of contact to find out the cool stuff that's going on. Okay, so now I'll get started. So about a year and a half ago now, actually, we saw something in space that we'd never seen before. And we saw this. This is very hard to see with this light, but they're black holes, so they're supposed to be hard to see. And there were 2 black holes, and they were circling around each other, and they got faster and faster and faster and closer and closer and closer together until eventually they get so close that they're traveling close to the speed of light, they touch, and then they merge into a single black hole. Now, this is something that had never been observed before. We didn't even know that black holes of this size existed before this measurement. And this measurement was made using something called gravitational waves. So gravitational waves are something that was predicted by Einstein about 101 years ago now, 102 years ago. And it's kind of like listening to space. Everything we know about the universe comes from electromagnetic radiation, whether that be optical or radio frequencies or X-rays or whatever. But this is something entirely new. And this is something that came out of Einstein's theory of general relativity, that basically said when huge masses move around very, very rapidly, these waves will ripple out in space itself. And what they do is they change the separation of objects very, very slightly. And so we wanted to measure these gravitational waves for 2 reasons. The first one was to check if it was consistent with general relativity. The second one is it gives us a new sense. It gives us a new way of observing the universe. It's very, very similar to listening to the universe as opposed to seeing the universe. So we're basically building these ears. These are the signals that appeared. There's three plots here. The first plot is one of the detectors, which is that one is in Hanford, and that's in Washington State, up in the northwest of the US, in the middle of a nuclear wasteland desert, where we built the first detector. The second plot is down in Livingston, in Louisiana, way down in the southeast of the US, just near New Orleans. And then when you combine these two and shift them appropriately in time, you can see they line up really nicely.